Still mixing up Rinnis and Weber's? In the next 3 minutes, you will never confuse them again. Let's quickly revise tuning fork tests for clinical examination. We usually use 512 tuning fork for hearing assessment because it lies in the speech frequency range, so it is ideal for the tuning fork test. What actually these air conduction and bone conduction? Actually, tuning forks based on comparing these two, air conduction and bone conduction. So, air conduction occurs through the external ear, tympanic membrane, ossicles, and then cochlea. But in case of bone conduction, it bypasses the external ear and middle ear, stimulates the cochlea. It directly stimulates the cochlea to by vibrating the skull bones, right? So by comparing these two, air conduction and bone conduction, we can differentiate conductive hearing loss and sensory neural hearing loss. So now let's discuss Rinne's test. So Rinne's test compares the air conduction and bone conduction in the same ear. How do we do Rinne's test? Strike the 512H tuning fork and place it on the mastoid to test the bone conduction. So here we are testing bone conduction. And when the patient stops hearing the sound, move the fork near the external auditory meatus to test air conduction. So if air conduction is more than bone conduction, it is Rinne's positive, right? So where do we get this Rinne's positive? In normal ear and also sensory neural hearing loss. If the bone conduction is more than air conduction, it is Rinne's negative. Where do we get this Rinne's negative? Yes, in conductive hearing loss, Weber's test. So how do we do Weber's test? Place the vibrating tuning fork in the midline of the forehead. Here we check for the lateralization. So we keep the tuning fork in the midline. Ask the patient where the sound is heard. So if the so if there is no lateralization, so hearing is normal. Sound is heard in the midline. So it is a normal hearing. There is no pathology in the ears. So if the sound lateralizes to the opposite side of the affected ear, so then it is sensory neural hearing loss. If the sound lateralizes to the same side of the affected ear, conductive hearing loss. Yeah, here comes the confusion. So I will give you a mnemonic to remember this. That is SOX. Remember SOX. S means sensory neural hearing loss. In sensory neural hearing loss, mm, sound lateralized to the opposite ear. Remember this. O is opposite ear. In sensory neural hearing loss, sound lateralized towards the opposite ear. And in conductive hearing loss, this is conductive hearing loss. In the sound lateralized to the same ear, to the pathology side. So, for example, if the right ear has conductive hearing loss, so we do Weber's test. We place the tuning fork in the midline, right? So, uh, which side the sound get lateralized? Yes, C, S, SOX. Conductive hearing loss, same side. So, sound lateralized towards the right ear, right? Now, let's test our understanding with another example. So these are right ear, left ear. In the right ear, patient is having sensory neural hearing loss. So we are doing Weber's test. We place the tuning fork in the midline. To which side the sound get lateralizes? Yes, see the mnemonic? Sensory neural hearing loss, lateralize it towards the opposite side. Yes, so towards the left ear, sound lateralizes. Sound lateralizes towards the left ear because right ear is having sensory neural hearing loss. So here in this case, right ear having conductive hearing loss. So sound lateralizes towards the right ear itself to the same side of the pathology. Sensory neural hearing loss lateralizes towards the opposite ear. Conductive hearing loss lateralizes towards the same side. So this is about Weber's test. I hope you understand the um, Weber's test now.